Hello everyone, I'm Adrian from the Things Industries, and today I'm going to be talking about how you can design your IoT systems integrations. We are going to talk a bit about what systems integrations are, how you should be thinking about them, and finally some of my tips and tricks about how you should design them. So at heart, systems integrations deal with integrating data between an IoT platform and an ERP system. Businesses have went and spent so many resources and so much time into building those ERP systems that for them it's very important that data reaches the ERP system instead of them having one extra platform to visualize and process all of this data. So instead of trying to replace the ERP system, you should think about how you can get your data inside one of those. IoT data in general needs to be ingested by those integrations and be processed in real time as it reaches almost the ERP system. And you are going to have large volumes of end devices, tens of thousands, hundreds of thousands of end devices, each of them sending an amount of data periodically in general. Due to those requirements, you need to actually think from the start of the scale which your software is going to run. And I'm going to give you some tips and tricks about what you should be thinking about while designing one of those integrations. First of all, everything starts with the API. You are going to need to make sure that the API has a clear specification, or as clear as it possible, on the fields and their semantics, on the messages that are going to be exchanged and when the exchange is going to happen. This is very important. It's the base of your system, and you must make sure that this is clear from the start. Once this is clear, you can start building everything else since you have a good foundation. Now, when it comes to IoT, one of the best ways of designing an integration for IoT is to think in event-driven systems. Basically, you are going to react to events being the messages from the end devices, maybe the fact that the device has joined your network, left your network, is now available or was not available before, and so forth. This means that you are going to be ingesting events. The IoT platform pushes events towards you, and then you do something with the event, and slowly through processing is going to reach your ERP platform. The important thing to realize here is that since messages are pushed to you, you can be reactive. When the message comes, you decide what to do with it. The best way of thinking about this is to think of functions. Functions which take the message, do some processing, and this result either goes into the ERP system directly or goes into another function that does the same. You are going to be thinking in functions, each with their own independent architecture, each with their own independent scope, and you are going to compose them. The message goes through one way, transformation occurs, another one occurs, finally the message is sent to the ERP system. And the beauty of such an architecture is the fact that you are going to be very easily scaling it. At heart, when you are in this mindset of actually doing processing with the result of the last step and not having any other state, maybe you can call a separate database but not keep the state into the function itself, is that you can scale it up and down very easily. You can scale horizontally, having multiple functions run at the same time, or scaling vertically by adding more resources to a singular function. The advantage here is that at heart, when you do this, the functions may run anywhere. And because they can run anywhere, of course, they can run as many times as you want with whatever size you need. From here, this is going to be a huge cost saver for you, because when you can actually adapt to the flow of data that you have. Data, although it is periodical, it doesn't have the same volume over time. Maybe throughout the day you are going to have larger volumes than throughout the night. So during the day, you can have a larger deployment of servers processing those messages, running the functions that transform the data, and during the night you can scale down as the volume is lower. This allows you to run 24/7 with minimal costs. The important part about this whole architecture is that you are stateless. The functions, the transformations that we are talking about now, are going to only process whatever input that was given to them and maybe call another service or call another database at most. They should never keep anything else in memory. If you do this, you can scale very easily. The next important trick that you need to keep in mind is that you should design with monitoring in mind. When I say monitoring, I'm thinking about the following two things. Metrics. How many messages did I process? How many messages had a particular type? How many messages failed? What was the distribution of failures? Maybe some of them were because the service was down in the last hour. Getting those type of insights about how your integration works. So here are metrics. They provide actual data on their own and allow you to be proactive about how your system runs. This will allow you to see, hey, now we've been steadily increasing the number of data that we've been processing throughout the day. We should actually scale now. We should increase the number of servers that we run throughout the day. And this allows you to be proactive. You don't actually have to react to the call from the customer that says that he no longer receives his messages. Instead, you can see it from ahead of time and react to it and be a very good system provider. Also, another part of monitoring is traceability. As your messages get processed by this pipeline that I have described earlier, you can actually emit events yourself. Those events can be processed by functions, and suddenly you have a beautiful way of building workflows. When you receive the message, it's then sent to the ERP system, but in parallel, maybe it triggers an SMS. The gateway says that it's now faulty. You can automatically trigger a service request and have someone look at it physically on site without needing actually anyone looking at metrics. You can all fully automate this by emitting events. And this monitoring mindset should be there from the start. As you are designing your architecture, you should build it with monitoring first. This means having those metrics and those events there from the day one. When you are going to use them, you are going to use them, but they should be already there. Otherwise, you are going to have to be reactive instead of being proactive. For this, you actually can use a lot of open source tools. The best ones which I can give you as a heads up are Prometheus and Grafana. Prometheus is a time series database which allows you to actually store those metrics that your services may produce, and Grafana allows you to nicely visualize them. Those tools you can run locally on your development machines. You can actually have them in all of your environments and allow you to design with monitoring in mind. When you are at scale, when you have tens of thousands of servers, tens of thousands to hundreds of thousands of end devices in the field, you cannot have people manually managing each one of them. You need to have aggregations and you need to have insights already being built for you automatically. Otherwise, your costs are going to catch up on you and you are going to have big troubles. So, those are my main tips and tricks. And please remember one very important fact. IoT works best when you don't know it's IoT. It shouldn't be visible to your final user, the fact that you're doing IoT. It should just work. Thank you.